Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant, and elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires two other cutting-edge technologies: the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the piste de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you move this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What of you? Discovered in 2017, KELT-9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT-9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, this signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss, because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles in light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our Sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom, we've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future. Imagine a giant, immensely powerful storm rotating over your head. You'd be terrified if you could see it. But this storm is invisible to the unaided eye. It isn't your regular hurricane. This intense phenomenon happens in space. Space hurricanes are giant swirling storms that form not in our oceans, but up in the ionosphere. It's part of Earth's upper atmosphere charged with energy from the sun. Space storms look a lot like traditional hurricanes, except they're made up of plasma, supercharged gases, and instead of raining water, they rain electrons. These massive rotating hurricanes appear over Earth's polar regions. Now, think of a space hurricane as a giant funnel or whirlpool of energy spiraling over the polar regions. It's only visible from high altitudes or by satellites. Space hurricanes also produce cyclone-like auroras. Such colorful light shows look similar to good old auroras, but there's a big twist. Space auroras usually spin near the North Pole for several hours, raining charged particles into the upper atmosphere. Hurricanes on Earth are born from warm ocean water and low-pressure areas. They're fueled by Earth's rotation and heat energy from the ocean. Space hurricanes, on the other hand, are created by a different process altogether. They're influenced by magnetic fields instead of Earth's water. When the solar wind, a steady flow of charged particles coming from the Sun, comes into contact with Earth's magnetic field in just the right way, it creates a kind of swirling vortex of energy high up in the ionosphere. It starts spinning, much like how a regular hurricane spins in the atmosphere. Now, let's go all the way back to 2014. That was the first time researchers spotted a massive space storm over the Arctic using satellite data. That hurricane was huge, but at that time, they didn't know exactly what it was. What they did know was that its base stretched over 600 miles in diameter, and it had multiple spiral arms that looked just like the arms of a traditional hurricane. The storm also had a calm eye in the center. There, the plasma was still compared to the fast-rotating outer regions. Some parts of this storm spun at speeds up to 4,700 miles per hour. It's an incredible speed compared to Earth's hurricanes. The team observed the phenomenon for 8 hours. After that, it gradually broke down. Scientists managed to identify this storm as a space hurricane only in 2021, using observations that had been made several years before. Space hurricanes have several distinct features. First, it's cyclone-shaped, massive, bright auroras that can last for hours. Then there's the eye of the storm, a calm, stable center of the hurricane. A space hurricane also creates a circular magnetic field with strong disturbances around it. Plus, scientists mention electron rains in the ionosphere. These rains are what causes those bright, colorful auroras right below the storm. But how do space hurricanes form? To understand this process, we need to first talk about regular auroras, like the northern lights. The sun emits a stream of charged particles, also known as the solar wind, non-stop. And sometimes, this wind brings massive bursts of energy towards Earth. Luckily, Earth has a magnetic field that acts like a shield, protecting us from most of this high-energy solar radiation. But when solar winds are too strong, they can get into the upper atmosphere, especially near the poles. When these particles from the sun hit Earth's magnetic field, they release energy that lights up the sky in the form of auroras. Now, in a typical aurora, electrons from the solar wind excite nitrogen and oxygen molecules in the atmosphere, which then emit light, leading to colorful shows in the sky. Space hurricanes are similar, but they happen at higher latitudes, above the region where auroras usually appear. They create a swirling, cyclone-like effect that looks quite different. Scientists are still studying the exact conditions necessary for a space hurricane to occur. But they already know that, surprisingly, such storms happen during very calm space weather. This is the opposite of traditional geomagnetic storms, which need intense solar activity. Space hurricanes need just the right balance of low solar wind and northward-pointing magnetic fields. And even though these storms are uncommon, they aren't impossible, hence those unique swirling storms above the poles. When scientists observe the space hurricane over the North Pole, they notice some shocking similarities to hurricanes on Earth. Just like the typical hurricane, a space hurricane has a central area where the plasma is calm. Even more curiously, the plasma in space hurricanes spins in a counterclockwise direction, which is like hurricanes raging in the northern hemisphere. The space hurricane also has multiple spiral arms, just like the ones you can see in satellite images of Earth hurricanes. Plus, the space hurricane doesn't need the strong solar winds that typically create disturbances in our atmosphere. No, it forms in periods of calm, just like how an Earth hurricane can only form if the winds in the atmosphere aren't too disruptive. Now, space hurricanes may be high above us, but they can still affect our daily lives, especially in areas related to satellite communications and space navigation. Those electron rains caused by the storm interfere with radio signals that travel through the upper atmosphere. It can disrupt GPS systems, radio communications, and radar systems. What's even worse, this interference can impact the orbits of space debris or space junk, which is already a problem for spacecraft and satellites in low Earth orbit. The storm's electron rain slightly heats up the atmosphere, which leads to extra drag on satellites and can potentially change their orbits. At the same time, the effects space hurricanes have on Earth aren't as direct and disastrous as those of hurricanes down here. They really don't pose any serious health risks to astronauts or damage satellites. But researchers say that studying such storms can help improve predictions for satellite operations, especially for flights that cross polar regions. Now, interestingly, scientists didn't set out to find space hurricanes when they spotted one. The discovery was a total accident. It happened when Larry Lyons, a space physicist from UCLA, and his team were looking through satellite data for another study. In this study, they noticed unusually strong plasma flows in the polar cap, the region at Earth's poles where auroras usually don't appear. When they looked more closely, they saw that this plasma wasn't just flowing, it was swirling, creating a circular pattern with a bright auroral spot in the middle. The researchers were intrigued. They analyzed over 300 different space hurricane events that happened over a span of 11 years. These storms appeared most often in the afternoon during summer months. It made the scientists believe there might be certain times and conditions that could encourage their formation. Luckily, with new research tools and techniques, scientists have been able to identify space hurricanes with greater precision. And recently, they've spotted parallel storms happening near the South Pole as well. The most exciting thing about this research is that it might help us better understand Earth's space neighborhood and the way solar energy affects it. Scientists like Lyons believe that space hurricanes may not actually be a new phenomenon. They may have been occurring for a long time, but no one noticed them. Space plasma physicists point out that space hurricanes resemble a phenomenon people observed earlier. It's called high-latitude day-side auroras. At the same time, space hurricanes are much brighter, and they have stronger circular flows, which give them those hurricane-like arms. Understanding space hurricanes could eventually help scientists predict them. It would be useful for planning space missions and making satellites more reliable. Plus, by looking at these storms, researchers hope to create a more complete picture of how auroras behave at higher latitudes. And even though space hurricanes may seem purely like scientific curiosity, they can give us important clues about how Earth's magnetic field and atmosphere interact with the solar wind. And who knows? This understanding might even help us spot similar storms on other planets with magnetic fields. It could offer clues about magnetic storms beyond Earth.
Black holes tearing apart enormous stars, pulsars spinning at incredible speeds and emitting powerful beams of energy, colorful nebulae with fireworks of newborn stars, galaxies of every possible color and size. All of these are found within our universe, but it's not infinite. It has a boundary, a literal wall, and beyond that, there's an absolute nothingness. Right now, we're going to make a journey to that wall. But first things first, our universe is like a humongous nesting doll. If you open it up, there's a smaller one inside. It's a galaxy. Inside that is an even smaller doll. That's our solar system. And the smallest doll of all is the Earth. Each of these dolls has boundaries that we're going to cross. For that, we'll need a spaceship, and a big one. It also has to be able to move 100 times faster than the speed of light. You get on board and start the engines. 62 miles above sea level is our first boundary. That's 10 times higher than passenger planes fly. This point is called the Kármán line. It separates the atmosphere of the Earth from outer space. Now we fly further, to the edge of our solar system. We turn on the hyperdrives and fly past Mars, Jupiter, Saturn, Uranus, and Neptune. We've traveled a distance of 100 astronomical units. 1 AU is the distance from Earth to the Sun. And here's the boundary of our solar system, the heliosphere. Here, the speed of the solar wind decreases rapidly. First, it drops from 620,000 miles per hour to the speed of sound. Then, there's a layer called the heliopause. This is where the wind almost vanishes. And then, our ship experiences a bow wave. This is where we feel the force of the interstellar wind, which collides with the boundary of our solar system. When you pass this boundary, you find yourself in the dark of interstellar space. And here, you can find two human-made objects that made this trip for the first time in history. They're Voyager 1 and Voyager 2. Voyager 1 crossed that boundary in 2004. Voyager 2 did it in 2007. These space probes discovered that the heliosphere is not a perfect ball around the sun. Its southern boundary is 10 AUs closer to the star than the northern one. So, we're moving in interstellar space and will soon approach a stone wall around our solar system. 200,000 AUs further, and there it is. This wall of rock is the Oort cloud. In fact, it's a pile of asteroids that surround our world. Scientists speculate that the Oort cloud could be the source of comets and meteorites that fall to Earth, but they're so sparse that we easily fly between them. Now we're in complete darkness. The Milky Way is about 106,000 light-years wide. In a conventional rocket, it would take billions of years to fly across that distance. But you throttle to the max. You masterfully fly past the stars and planets as if on a racetrack. And within minutes, you're at the edge of our galaxy. There's no more interstellar wind. All you see are bright dots somewhere in the distance. These dots are huge galaxies. We need to look at a map to make a route to the edge of our entire universe. You're here, near the Milky Way galaxy. It's part of a cluster of galaxies called the Laniakea supercluster. But even this huge thing is like a little street in a big city. Zooming out, we find Hydra Centaurus supercluster. Thousands of galaxies on the map look like little dots. Maximum zoom out. This is our entire observable universe. We thought it was infinite, but we may have proof that it has a boundary. It's here, 10 billion light-years away from our home. Even if you travel at the speed of light, a trip there would take twice as long as our whole planet has existed. During that time, the sun will either fade away or explode like a supernova, destroying our entire solar system. And if you can live that long and then return home, you will see that our galaxy is there no more. It's long since collided with the Andromeda galaxy and merged into one big cosmic body. Luckily, your ship is able to warp space-time so that this journey will literally take a few seconds. Boom! Congratulations! You've arrived at your destination, the Eridanus supervoid. Some scientists believe this location is the evidence of collisions of our universe with something big enough to leave such a large scar. The Eridanus supervoid is an empty and cold space 1 billion light-years wide. If you think of this void as a cup, it would fit at least 10,000 galaxies, and it appeared after an accident of gigantic proportions. The object that crashed into our universe was another universe. Yes, other universes may actually exist. Imagine that our entire universe is a huge bubble that contains all the clusters of galaxies in the observable universe. There could be an infinite number of such bubbles. They could have been born during the Big Bang. These universes may be different from ours. They may have other galaxies and nebulae. But these bubbles could also be parallel universes. This means that if you chose cereal over oatmeal in the morning, in another universe, your twin would choose the oatmeal. Every choice you ever made in life had completely different consequences in a parallel universe. And because the number of choices are infinite, there's a whole infinity of parallel universes. So, like a regular bubble, our universe has a wall that is near the Eridanus supervoid. Long ago, another bubble flew past ours. As they approached each other, their gravitational fields began to interact. Our boundary wall began to deform and pull toward the other universe. The same thing happened on the other side. Then the walls of our universes came into contact. But as these bubbles moved, their connection began to break, and the other universe just ripped a huge chunk of ours. A cold void was formed at the point of collision, and that was the Eridanus supervoid. The problem is that the universe looks the same to the observer, regardless of point of view. For example, imagine a basketball hanging in the air. Now, if we put an ant on the ball and tell it to find the edge of the ball, it will start running around it, making an infinite number of circles. But the landscape around the ant will not change. All it will see is a rounded horizon. That's because the ball remains the same from any point of view. The same thing happens to us when we try to find the edge of our universe, all because we imagine the world in three-dimensional space, and our view is limited. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, voila, it's a cube. If we could see the universe in four-dimensional space, a square might be something completely different. But maybe we can leave our home bubble. The key to traveling to another universe might be inside a black hole. A black hole is one of the most mysterious objects in the universe. They're so heavy, they warp not only space, but time as well. It's like putting a heavy boulder on a net. The net will sag, and the closer you get to the boulder, the stronger the curvature is. Once you're in the gravitational field of a black hole, you can't leave it. We still don't know what might actually be in the heart of a black hole. Some scientists speculate that white holes also exist. Theoretically, they should be born along with black holes. Except for the color, they're the exact opposite of black holes. Nothing can come close to a white hole. At the moment, there's no data on such objects, but general relativity theory suggests they do exist. There's also a theory that a black hole may be a passage to another universe. When you get into a black hole, you can come out the other side through the event horizon of the white hole. So you bypass the boundary of the universes and find yourself in a completely different world. But we may have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy somewhere 1.6 billion light-years away from Earth. This burst was unique. It didn't look like a supernova explosion or even the merger of two black holes. Some astronomers believe it was the birth of a white hole. But because it was unstable, it was destroyed almost immediately. This process was reminiscent of the birth of our entire universe, the Big Bang. So, scientists called it the Little Bang.
NASA sent a spacecraft right into the sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the Moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the Moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the Moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the Moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the Moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush. Because apparently, precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.
Now, you've seen those breathtaking images from NASA. Stars born in clouds of gas, tangled galaxies, colors that look fantastic and vivid. And then someone suddenly says that this isn't real, that NASA edits all these pictures. Well, guess what? They're right. NASA does edit their photos, every single one. The catch is that it's not to deceive us, but rather to reveal what we could never see on our own. You see, color is a weird thing. It's just waves of light and energy flying through space. When these waves hit some object, a banana, a chair, or even a dust particle, the objects absorb some of the waves, eating a part of the spectrum. But some of it bounces back into our eyes. That bounced light is what we perceive as the object's color. There's an entire spectrum of these waves, from short ones to long ones. As they get longer, they move to the red spectrum and turn into infrared, microwaves, and radio waves. As they get shorter, they move closer to blue and violet, turning into ultraviolet, X-rays, and gamma rays. Now, right in the middle of that spectrum is a tiny band we call visible light, which is the only part our eyes can see. That's the rainbow we all know and love, and it's an exceedingly small part. So, you might say we barely see the world at all. When light bounces off something and gets into our eyes, our color-detecting cells, called cones, send them to our brain. So, when we say, banana is yellow, it means banana ate red, green, and blue waves and reflected yellow waves into our eyes. So, the question is space actually that pretty and colorful, or is it all fake? Well, yes and no. Stars emit light, and it travels through space like an unstoppable train. It's flying there, chilling, until it hits something – dust particles, a planet, spaceship, or an astronaut. Every time light hits something, some of it gets absorbed, some of it reflects and continues to travel. So we get less and less light every time it hits something. And when you enter a nebula, which is basically tons of dust particles around a gas cloud, light quickly starts to scatter and disappear. Nebulae, which is the plural of nebula, also grow naturally from ionized gases like hydrogen, oxygen, sulfur, radiating light in specific spectral lines. But it's super faint as well. Remember, our eyes see things only when light bounces off those things in our eyes. On top of that, the color-detecting cones in our eyes aren't so great, in that they need lots of light to activate. We can't see faint stuff. Unless there's something emitting light right there nearby, we wouldn't see anything. In other words, for us, the entire space would be like a room with lights turned off. The potentially beautiful nebulas and planets are there, but if you don't have a lamp nearby, you can't see them in all their glory. When there's lots of light around, rods take over, another type of cell that's great for motion and dark vision, but terrible for color. So in deep space, all we'd see are dim whites and grays. Now, if you were flying around on a spaceship, the stars would look sharp, white, and non-twinkling. You'd be able to see some reddish or bluish tints to the brighter ones, like Betelgeuse or Rigel. But a lot of things would be dim gray smudges at best. The Milky Way might appear as a cloudy band, not rainbowy like in astrophotography. Nebulae would look like faint fuzzy clouds with no color, unless it's something that glows very brightly, like the Orion Nebula. In our solar system, astronauts can see stuff thanks to the sun or when they're near illuminated planets or spacecraft. Planets like Jupiter and Mars retain some color for our eyes. Meanwhile, on Earth, the sky would look black during the day if we had no atmosphere. The sun would be a bright disk in a void as seen from the moon. If only we had super-sensitive cone cells that could detect light better than we do and see even faint things. Oh wait, we actually do have technology for that. Long-exposure cameras and telescopes. Now, telescopes are great for that. They often use long exposures to gather light over minutes or entire hours. That lets them capture photons we'd never collect with our eyes. When telescopes like Hubble or the James Webb take photos, they're not snapping pretty pics like those on Instagram. They're collecting all this raw, invisible data, numbers and faint light that's both within and beyond human vision. The James Webb Space Telescope doesn't even see visible light. It's built to detect infrared or heat. Telescopes like that work like time machines. They show not only distant galaxies, but also what those galaxies looked like billions of years ago. We see stars that have long since gone out, and galaxies that may have already disappeared. All because the James Webb can pierce through gas and dust and see galaxies so old that their light has been stretched into infrared wavelengths as the universe expands. In other words, this telescope isn't made to let us take aesthetic photos. Its main goal is to study the history of the universe. Now, at first, this stuff looks like grayscale or even black images. When the James Webb sends data back, it looks empty. But during post-processing, astronomers map wavelengths they received to visible colors. Every color in those pictures is chosen for a reason. It highlights specific wavelengths, gases, or temperatures. In any case, it shows what would otherwise be completely hidden from our eyes. Sometimes they show only stuff a human eye can see. Sometimes they shift colors or add something to show elements or intensities. For example, let's say you're studying a supernova, a star blowing itself to pieces. You need to see its debris clearly to understand what's going on. That means you'd play with the contrast or adjust color balance to reveal specific gases and find pale objects near bright ones. Want to check out a weird rock on Mars? You zoom in, adjust the lighting, boost the shadows. Photographers do this every day. So scientists do it too, because clarity means understanding. Even old photos from the Apollo missions have been touched up in modern times. It's like restoring an old film so it looks crystal clear instead of foggy. Without this editing, the most incredible discoveries of the past 2 years, those first galaxies, those newborn stars inside cosmic clouds, would just look static. Is it possible to accidentally misinterpret the color? Of course! For example, images we get of Mars are mostly red, but when we land on a planet, it's more colorful. Most of it is gold, yellowish, tan, or brown. The reason Mars looks reddish is due to rusting iron in the rocks, Martian soil, and dust. It all depends on the lighting, atmospheric dust, and image processing methods. But the fantastic colors themselves are not made up. Galaxies contain billions of stars, gas, and dust, giving off incredibly rich color ranges. NASA's photos are basically translations. Now here's an interesting take. Could we use goggles with night vision or some technology that makes our eyes notice light better, like working with Hubble or the James Webb? Man, the sky would be insane. You'd never be able to sleep again. These magical astronomy glasses should greatly amplify faint light, enhancing and translating colors. Unfortunately, today's night vision tech won't cut it. Night vision goggles work by amplifying visible and near-infrared light, but they display everything in green monochrome, not true color. Meanwhile, infrared goggles detect heat, not color. We need some goggles that raise photon sensitivities by 10,000 or so. If only we were lucky enough, like some animals. For example, snakes can see infrared, bees see ultraviolet light, and birds see more colors than we do. And we can't even imagine how they perceive the world. So yeah, NASA edits their photos, because raw space isn't built for our eyes. It's dark, cold, distant, and silent. But with a little translation, some math, some color grading, some visual storytelling, we can see the invisible. We can study the past and inspire more people to study space in the future.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of -418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey, smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with them on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect.
On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guest said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new: a bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things: really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear: the typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion. which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters overmassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when 2 magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars and the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with 2 blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old. And from what we can see, one mysterious star, HD 11402883, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is, at least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, It's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space.
They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Webb's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small. They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb Telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold. But in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition, and the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.
Houston, we've got good news. A group of select humans is being interviewed to hop on board the first commercial vacation to outer space. The space agency has given you a survey to answer. They want to know what you would pack on this space adventure. Depending on your answers, you just might be one of the chosen ones. Now, how about we take a look at that list together? Pencils. I guess I never would have thought of that, but it makes sense. Legend has it that the US spent millions of dollars trying to design a pen that worked in space. You know, since the lack of gravity is a huge, inescapable factor of life in outer space, pens don't work. The ink won't flow down as it does here on Earth. It turns out that pencils will do the trick. This way you can play word puzzles with the other space tourists, or even make some drawings of your adventure. You'd never forget to pack a toothbrush, of course. According to veteran astronauts, toothbrushes are so simple, yet their technology is enough for space. If you were to squeeze a water bottle inside a spacecraft, the molecules of water would float around in small bubbles. But if you wet your toothbrush, it naturally holds the water in it, keeping it moist to receive your toothpaste. Oh, I was going to say funny socks. Glad that you beat me to it. Here are two things. First, there's not a lot of walking that goes on in space. People don't tend to touch the ground too much up there. And second, space isn't the best place to showcase your fashion style. Yeah! Astronauts tend to use special clothes while they're out there. And it will be no different for you as a space vacationer. So socks will keep your feet warm and fuzzy, but they'll also speak for your fashion interest. Maybe one day you'll wear a smiley face sock, while the other day you'll go for a Grinch-themed one. Of course, socks are pretty helpful on board an aircraft. They'll make you slide through stuff more easily. Next time I go to the convenience store, I'll remember to buy some wet wipes for your space travel. Experienced space travelers do love them. And it wasn't even NASA that invented them, huh? Since water is a no-go inside a spaceship, the best option is wet wipes. Better yet if they're scented. Astronauts even use different kinds of wipes. They buy the disinfecting ones and the ones to use on their bodies. Just make sure you know how to tell the difference between them when you're up there. There's a popular myth that says that NASA invented Velcro. But the truth is, we tend to think that everything that's used in space was invented by NASA for a very intelligent and specific purpose. It wasn't, though. Velcro was invented for mundane reasons back in the 1950s by a Swiss company. They were adopted by space travelers because they work as anti-gravity props. They don't erase gravity, of course. But you can glue Velcros into daily stuff and then hang them on the Velcro attached to the spaceship's walls. It's a very smart system, but best to take your own pair, right? If you're spending a long time in outer space, photographs from back home might come in handy. Choose them well, though. Since the spacecraft isn't all that big, the rest of the people on board will know which pictures you decided to bring along. Best to keep that Harry Styles poster back in your earthly bedroom, right? Just bring real pictures of people that you know and love. Did I hear pizza? A huge part of traveling and exploring new places is being able to taste different flavors of food. In outer space, that's a bit more complicated. But hey, at least you can take some pizza with you. Well, actually, you'd have to have it delivered to you in a cargo ship. This way, ingredients would come fresh and ready to eat. It wouldn't be the first time that people in space tried eating Earthling junk food. Some astronauts have even eaten crepes and hot dogs. Perhaps the best part of this pizza party would be that your food could float. Now, isn't this a super nice way to enjoy some Earth delicacies? As much as I understand your desire to pack a toilet with you on this space trip, that's virtually impossible. I understand you. Some people are attached to the toilets in their homes, and a space toilet is far from the ideal experience. But NASA has been improving their toilet system, and it's the best it's been over the years. So that will have to do. Here's something I would take as well. A laptop. But what good would it do in outer space, you might ask? Apparently, there is internet all over the International Space Station. So even if you're not spending most of your trip docked at the ISS, you could enjoy some Netflix on the days you spend over there. There is internet all over the ISS, apparently. Crazy, huh? And speaking of leisure, I love that you would take a yo-yo. I'm not sure how efficient it would be in space, since there's no gravity to bounce it back and forth. But it would be nice to see how a yo-yo reacts in a gravity-free environment. Oh, I love jigsaw puzzles. This would definitely be on my list as well. Imagine trying to build a jigsaw puzzle that keeps floating in the air. Maybe you'll have to create a system to avoid the separate pieces floating aimlessly through the spacecraft. But imagine once you finish that turtle puzzle, it will look like it's swimming around the craft. You can't pack a window, but they sure are an important part of life in outer space. Let's keep in mind some of the rules of the trip. Each traveler will have the opportunity to do one spacewalk during their time in space. This is already huge. Consider yourself lucky. Some elite astronauts only get to do one spacewalk during their entire career. That is so because spacewalks are risky and require a lot of training. But you'll get your training once you're up there. The thing is, all other days you'll be stuck inside a floating tin can. So windows will come a long way. They'll help to remind you where you are. They'll give you some perspective of space and Earth. Of course, you should take your camera. How else will you be able to register for this once-in-a-lifetime experience? Just make sure it works inside an aircraft or the ISS and you're good to go. Coffee? Don't worry, you don't need to pack your own. Up until recently, astronauts had to rely solely on instantly brewed cups of coffee when they were in space. But you're lucky that coffee experts have already solved this issue. Nowadays, there's the IS espresso machine. The machine itself is similar in size to an Earthling espresso machine. But to drink it, space travelers have to use a zero-gravity coffee cup together with a straw. If you try drinking it regularly, you wouldn't get hot coffee to hit you directly in your face. Instead, the coffee would be glued to the bottom of your cup. I have to say I really stand this invention. Last, but not least, why not pack your guitar with you? I noticed you were missing a musical instrument. If this was a conventional flight, you might have to pay extra for luggage. But since it's all included, don't be shy and take your guitar. Astronauts such as Chris Hadfield take their musical instruments with them when they're in space. He even became famous for his version of Bowie's Space Oddity, up to the point that Bowie himself told him he lived Chris's version of it. It helps to pass the time, but it's also great for socializing. Can you imagine a pretend bonfire happening in the void of space? I can, and it looks super cool. Well, I think you're set to go. I'll personally call NASA and ask them to pick you as one of the lucky space travelers. See you in outer space, amigo. It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth, and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.